Okay, so now we're going to move on and look at the higher paper. So what we've got here, what we've got here is the first 7 questions are the same as the last 7 questions of the foundation paper. So if you were, if you're not sure and you want to go through those, you can go through those questions on the foundation paper, but this is starting at question 8. So we want the exact value of tan 45. Now this is where you need to learn your exact values. And there's a few shortcuts to do this. So you can either prove it to yourself each time, or you can learn them using, there's different techniques, but I'm going to show you the one that I don't know, I think works the best. So when you've got your exact values of 0, you should have 0, 30, 45, 60, and 90. So you might have seen the hand method, but the method that will always work will be just to draw yourself some triangles. So you only need 2 triangles, and the 2 triangles you need will look like this. So you'll have one triangle, a right angle triangle, where both the opposite and the hypotenuse are 1. So it's an isosceles triangle. So these must be 45, and these will be root 2. And then we can find out, and we can see that sine 90 is 1, cos 90 is 0, tan 90 is undefined, but tan 45 is 1 over 1, which is 1. So this is the triangle we're going to use in this instant. So this is going to be 1. And then we've got a right angle triangle. We want to work out the value of x. So we know the adjacent and we know the hypotenuse. So if we take our TOA, adjacent and hypotenuse will be cos. So what we can see here is we've got cos 60 is the adjacent, which is 4, over the hypotenuse, which is x. Now, whenever you've got a fraction like this with one thing on the bottom, you just do a swap. So all you do is you swap those around. So you get x equals 4 over cos 60. You're told cos 60 is a half. So you've got 4 divided by 0.5. When you divide by the half, it's the same as timesing by 2. So x equals 8. So your final answer will be x equals 8. And they've given you all the information they need, and they typically will. Okay, question 9. So the times that 48 trains left a station on Monday were recorded. The cumulative frequency graph gives information about the number of minutes. The shortest is 0, the highest is 42. And you're going to have to draw a box plot. Now, to draw a box plot, you need the smallest, you need the biggest, and then you need the median and the interquartile range. Now, your median is the middle number, right? And we're talking about delays. So the middle number is, you're going to check out what your middle number is. So what you need to do is you read off from 50, halfway will be 25. You're going to go along, you're going to go down, and I get to 10. And to get your quartiles, what you're going to do is you're going to do half of the half. So what's halfway between 25 and 50? So you're going to go at 37, so here, and you're going to read off here where we've got 20. And so this is our medium, so this is our quarter 2. This is our upper quartile. And our lower quartile will be halfway here. So 25 divided by 2. So we're going to have each square down on 12 and a half. So we're going to read off here. And, we get, I think I get about here. So I get a value here which is 4, I think, and that's going to be my Q1. And now I have those 3 values, what I can do is I can plot my box plot. So remember, we've got 4, we've got 10, and we've got 20. So if I scroll up, what you can see is that you're going to draw now your box plot. So we're given the smallest number. So for the smallest number, we draw a line. Let me try doing a different color so you can see it. So we've got 0, and this is a bigger line. So let's say we make it that big. It doesn't really matter. As long as it's, you know, bigger than and in the center, you'll see what I mean. And then you've got 42. So even if you do nothing else, if you got really confused, you can draw those. And then we've got our median, which we found out to be 10. Our lower quartile, which was 4. So 1, 2, 3, 4. Upper quartile, which was 20. And what we do is with the quartiles, we make ourselves a box. You will do it beautifully with a ruler, and we've drawn a box plot. So this is our lowest value. This is our highest value. This is our second quarter. This is our first quarter, and this is Q3. I hope that makes sense. And then we're given another one for Tuesday. And the next question that's going to come, but we're going to talk about it looking at them, it says compare the distribution. Now, if you have a look, if we compare the medians, the median here is less than the median here. So we can say the median delay was bigger on Monday or smaller on Tuesday. Same thing, different words, doesn't matter. The interquartile range on Tuesday was lower. And we have the so what does that mean? So if your interquartile range is lower, so what we're saying is this space over here, so let me do it. So this bit of the box is smaller than this bit of the box. So that means your data is less spread out. So if you ever have to compare box plots, you're comparing the middle and you're comparing the spread. It's like comparing the mean and the standard deviation if you're given those as averages instead. Okay, so those are your comparisons which you're asked to do there. And then it says the longest delay on Tuesday was 33 minutes. This means there must be some delays of between 25 and 30. Well, no, there's nothing to tell us that. We don't know what numbers this is made up of. So Mary is not correct because we don't know if there were delays between 25 and 30. We only know that there were 12 delays between 17 and 33 because we only know the 3/4 amount. Okay, question 10. We're going to simplify this. So hopefully you can see. So what I would do is write my bracket. I've got x minus 1. And then I've got on the bottom x minus 1 squared, which means 2 lots of x minus 1. So this is really 1 lot of x minus 1. Get rid of them. We can only cancel if they're in brackets like that. And we get 1 over 5 x minus 1. That's nice and easy to simplify. Factorize. So you're going to take outside the brackets. Do the numbers first. The numbers are easy. What goes into 50 and into 2? That's going to be 2. So we're going to have 2, 25 minus y squared. And recognize that's a difference of 2 squares. There is always 1 in the exam paper. So 25 is a square. Y squared is a square. Whenever you've got 2 squared numbers and a minus between them, you can always write it as taking the square root of each one and putting a plus and minus, and that would be your final answer. So that would be factorized fully. Okay, question 11. Jack and Sadia work for a company that sells boxes of breakfast cereal. The company wants to have a special offer. Here is Jack's idea for the special offer. Put 25% more cereal into each box and do not change the price. And Sadia's is reduce the price and do not change the amount of cereal. Sadia wants her idea to give the same value for money as Jack's idea. Now, we could do it all in percentages, but sometimes that doesn't make sense for you. So what I would do is I would always pick some numbers and pick nice numbers, right? So let's say we're going to sell boxes of 100 grams, right, for 100 pence, right? And then it's easy to see the percentage changes. So that's what originally it is. So we're saying the boxes of cereal right now, I've just made up those numbers. I've chosen numbers that make it easy. So I'm going to put, for Jack, he's putting 25% more in. Now remember, 25% chosen 100, that's just saying he's chosen 125 grams and he hasn't changed the price, so he's still charging 100 pence. Now, that tells me that every gram, if you like, so 100 pence, so we could say 1 gram is 100 over 125. So that's what Jack's price gives us. Now, Sadia's idea is we don't change the amount of cereal, but we will have the same, we do not change the amount of cereal in each box, we just reduce the price. So we're saying, okay, so Jack gets to 100 grams being that, and we want to know, well, what would the original 100 grams be at that price? So we're going to times this side by 100. Okay, so it cancels down. We can divide top and bottom here. So you're just going to take your top and you're going to divide your bottom as well by 25. So you're going to get 4/5 times 100. 100 divided by 5 times by 4 is going to give you 80. So 80 pence. Right, so by what percentage does she need to reduce the price? She needs to go from 100 pence to 80 pence. So she's reducing it by 20%. And by thinking of it as real numbers, you stop yourself confusing yourself. If you wanted to do it mathematically, you could have said 125% for P, thought about what 25% was, and had it all in decimals. But I think this is easier. If in doubt, choose some numbers, particularly with proportions and percentages. Right, question 12. We want to find CAO. So that's CAO. So we want this angle here. That's what we're going for. Let's see what we know. We know that ACB is 56. This is that weird kind of Z angle inside a circle. It's called the alternate segment theory. So it's this weird angle that you get inside a circle. So you've got your alternate segment theory. Okay, we now know that OCB is also going to be, so if you have a look, if I split this here, this is a radius, this is a radius. We know that base angles are the same. So we know this bit is 35. Therefore, obviously you're writing it all out step by step. This bit here is going to be 21. Now, because you've got your base angles again, you've got two sides of the same, because again, they're radius of a circle. This is also going to be 21. So your angle of CAO is 21 degrees. You'd have to write out each step and you'd say ACB equals 56, alternate segment theorem. OCB is 35 because of the angles at the base of the isosceles. Therefore, OCA is 21, so CAO is 21. Right, question 13. Let's have a look. Oh. Right, we want to transformations. These are really easy. When we've got enlargements, there's a really easy way to do them. You take the points and you match them up. So what I'm going to do is I can see this is the corner, like your the right angle corner. We can match those up. These two, oh, I've drawn that a bit strange. Okay. These two match up with each other. I should be able to draw a straight line down. And then we've got these two matching up with each other. Okay. So you're going to do that with a ruler. Where your three lines meet is your center. So we can see that all three lines meet here. So straight away, I can say my center is 2, 2. Center, 2, 2. Right? I'm going from A to B. So I'm getting smaller, right? So it's getting smaller, but it's still called an enlargement. It's a bit weird, but like whether I get bigger or smaller, it's called an enlargement. Just write it. I flipped it, so I put a minus sign. And I say, how much smaller has it got? Well, this side is 3. This side is 1. This side is, so I've reduced it as by a third, but we can double check. This side is 2. This side is 2. This side is 6. Okay, so it's definitely reduced by 3. So I put the 3 on the bottom and it's a minus a third. So when it flips, you do a minus sign. Whenever you have a transformation, you need 3 things. You need the type, the center, and then by how much it's moved. Okay, question 14. We're going to work out the value of 16 over 81 to the power of 3/4. So we're going to split it up. We're first going to do the over a quarter bit. So it's the same as saying 1/4, then all of that cubed. So a quarter is the 4th root. To take a 4th root, you take a square root and then you square root it again. So you take 1 square root and you take the square root again. So the square root of 16 is 4. I square root it again and I get 2. The square root of 81 is 9. Square root it again, I get 3. And it's going to be cubed. So I'm going to get 8 over 27. So 2 cubed over 3 cubed. Right, now we've got A plus B plus C, and we're given everything in indices. So the thing is, we want to make everything in terms of 3s. So let's take that one there. We've got 3A equals 1 over 9. So over, the minute I see something on the bottom, I do a minus. How do I go from 3 to 9? I'm going to square it. So 1/9, that's the same as a 9th. So that tells me A equals -2. Right, next one. 9 is the same as 3 squared. Root 3 is the same as 3 to the half. When I times them, I add them. So I'm going to get 3 to the 2.5. Yeah, 2 plus a half. So B is 2.5 or 2.5. Right, here it's on the bottom. So 1 over root 3. So I'm going to do 3 to the minus. Root is a half, so a half. So C is -1/2. And I want A plus B plus C. So when I add them all up, I've mixed up decimals and fractions, but it doesn't really matter. I get 0. And so my answer is 0. Right, next question. We've got 3 solid shapes, A, B, and C. The surface area for shape A is 4, the surface area of B is 25, the ratio of volumes, and you want the ratio of heights. Okay, so in general, when we're talking about ratios and scale factors, what we have is we have your ratio of your lengths. So your ratios of your lengths are A to B. If I want to go from a ratio of the length to the area, what I've got to do is I square it. So square. So if I want to go to the area, it's going to be A squared to B squared. And if I want to go back to the length, obviously I take the square root. If I want to go from a length to a volume, I cube it. And then here I cube root it. But what you notice, if you were going from an area to a volume, you've got to go via the length. You can't jump straight here. You've got to figure out the length first, then go to the volume. So what that means in terms of this question is we've got the surface areas of shape A and B. I mean, it doesn't really matter if this shape A and B, which is 4 to 25. So that means this is for the area. So for the length, we have to take the square root. So we get 2 to 5. For B to C, for the volume, it's 27 to 64. We want to go to the length. Remember, we're always going back to the length. So we're taking the cube root to give us 3 and 4. And now we match them up. We've got A to B to C. The lengths here are 2 to 5, 3 to 4. We look at the ones that are the same, which is for B, and we go 5 times 3. That gives us 15. Then we say, how did we go from 5 to 15? We timesed by 3. So we have to do the same to the 2. So 2 times 3 will give us 6. How did we go from 3 to 15? We times by 5. So 4 times 5 is 20. Now we only really want, according to the question, we want A and C. So we've got 6 to 20, which we can half to give us 3 to 10. And that would be your answer. So you always, this is quite tricky because it had like sort of 2 steps to it. Right, next, question 16. Let's scroll it up. It's too far. So we've got recurring. And if you notice, the dot is only on the 5 and a 6. So we're going to let X or N, depending on what letter you've used when you've learned it, it doesn't really matter. So we're going to let X equal 0.525656565, because that's where the dots are. I can't take anything away until the end bits are all the same. So I'm going to first times it by 10. So I get 2.565656, because that's what that means. Now I want to get rid of this 5, 6. If I only times it by 10 more, it's going to be 6565. So I need to times it by 100 more, which gives me 1,000x. So I get 256.5656. Now, when I do this one, take away this one, I'm going to get 1,000 minus 10, which is going to give me 990. And here, when I take these away, all these 5 6s are going to cancel out. And I've got 256 minus 2, which is 254. So X must be 254 over 990. And I'm not going to spend ages halving it. I'm going to say this equals 127 over 495. And I'm just going to double it to check it makes sense, which it does. Right, so that's 16. Let's have a look at question 17. Right, here is a sketch of a graph. The point 0 minus 5, so 0 minus 5, that's here, and 5, 0 lie on the graph. So that must be 5. Right, and I'm like, okay, so straight away, I can see my plus C, my bit that doesn't have an X next to it, must be minus 5. So I know that B is minus 5. So I've got y equals x squared plus ax minus 5. And now I just stick in my other coordinate, because I know when x equals 5, y equals 0. So 0 equals 25 plus 5a minus 5. So 20 plus 5a equals 0. 5a equals minus 20. So a equals minus 4. So now I know, we're not quite there yet, we've just got the equation of the graph. Y equals x squared minus 4x minus 5. I want the turning point, which means I need to complete the square. Okay, I can do it. I'm going to need to complete the square. So if I complete the square, I half what's in front of the x. So I get x minus 2 squared. I take this number that's here and I square it. Doesn't matter if it's positive or negative, you're always going to minus it. So you minus this number, so you minus 4, and you've also got your minus 5. So x minus 2 squared minus 9. So that tells us that the turning point is 2 minus 9. Right. Next question, question 18. So we've got a graph of y equals fx, and then we've got to sketch x minus 2. Inside the bracket affects the x. X's are bad. They're like your ex-girlfriend, boyfriend, friend, whatever. They do the wrong thing. So if it says minus 2, it really means plus 2. So the x's are always inside the bracket. They always do the wrong thing. You're shifting it to in the positive direction. So it's going to go through those two, and your graph is going to look like that. Next one. We've got a graph that's been reflected, and we want to write down the equation. Okay, so it's been reflected. All the x's have swapped. Can you see that? So if you look here, the x on the original graph is over here, and the x is here, but the y's have stayed the same. So the change is inside the bracket. Inside the bracket affects the x. So inside the bracket has become minus what you expected it to be. Your x's in brackets, don't want them. So they stay inside the bracket. Everything except for minusing it is always the opposite. There's not really an opposite to a reflection. So that's how you do that one. Right, next question. We've got a functions question. GFX. So you always put the second one into the first one. So you're putting F into G. So wherever there's an X in G, you're replacing it with all of this. So we've got GFX equals 2 lots of x plus 1 squared minus 1. Right, so we're going to open that out. So remember, when we've got something all squared, we square the first number. We times the two numbers together. So x times 1 and double it. Oh, it says I've lost connection. Sorry, I think I've lost connection on my TikTok. Right, if you're, I'll try that again. Apologies if you're watching on YouTube. I'm just going to try connect my TikTok again. I hadn't realized I'd lost connection there. I wasn't really paying attention. Let's try that. Right. Okay, so hopefully this has come back. So we've got x squared plus 2x plus 1 minus 1. So we've got 2x squared plus 2x, and then we can take x outside the bracket and we get x plus 2. And then we've got to find the inverse g to the minus 1 x, 7. Sorry if you guys were connected earlier, my phone lost connection. Hopefully you found me on YouTube. We're up to question 19 now, but this will be saved on YouTube and you can replay bits. Right, so we've got g to the minus 1x. So we want to find the inverse, which means what we do for g is we take, so I'm going to rewrite g up here for you. So gx was 2x minus 1. So gx equals 2x minus 2. So that's the same as saying y equals 2x minus 2. We're going to swap our x's and our y's. So when we swap our x's and our y's over, we get that. And we rearrange to make y the subject of the formula. So we're going to get 2y equals x plus 2. So y equals x plus 2 over 2. And now what we're going to do is substitute in 7. So 7 plus 2. So g to the minus 1, 7 is going to be 7 plus 2 over 2, which is 9 over 2, which is 4.5. Or you could have left it as 9 over 2. Right, question 20. Right, this was not a nice question. It's quite long. So we're going to go through slowly. Surds always comes up on a non-calculator paper. So you can expect to get a surds question, but they're not difficult. You've just got to break it down. So let's try break down what we've got. First thing I would do is take each of these individual ones and simplify them. So we're going to simplify root 18 and root 8. Now surds are easy. You only need 2 formulas. You only need to know 2 rules rather. So 2 rules, one rule is that, and the other one is root a over root b equals the square root of a over b. Those are the only 2 rules you ever need. So let's have a look. Root 18 is going to be the same as root 9 times by root 2. So it's 3 root 2. Root 8 is the same as root 4 times root 2. So 2 root 2. So do your simplifying first and then put the numbers in. So instead of root 18, we're going to write 3 root 2. And we've got plus root 2 all squared. Instead of root 8, I'm writing 2 root 2 minus 2. Okay, so 3 root 2 plus root 2 is 4 lots of root 2. 2 root 2 minus 2, well, I can't really do much there, so we're going to just leave it like that. Right, let's square the top. 4 squared is 16. Root 2 squared is 2. So on the top, we get 32 over 2 root 2 minus 2. It's still not in this form because we've got surd on the bottom. We don't like surds on the bottom. So what we're going to do is times top and bottom by 2 root 2 plus 2. And when we open out these brackets, we get 32 times by 2, which is going to give you 64 root 2. And then 32 times 2 to give you 64. And on the bottom, you've got a difference of 2 squares. So 2 root 2 squared gives you 8, because we just worked that out. But anyway, root 2 squared is 2, 2 squared is 4. And then we know that 2 squared is 4, so we get 8 minus 4, so 4 on the bottom. So now we're left with, Let's try and write it somewhere you can see. So our final answer, we've got 64 root 2 plus 64 over 4. We can divide everything by 4 to give us 16 root 2 plus 16, which if we want to make it look like this is the same as 16, 1 plus root 2. And I agree, that's not a nice question, but you've got to go step by step by step. And even getting yourself to this point gets you more than half the marks. Okay, so we've got 2 more questions left, both of which quite long, but we should be okay. So well done if you stuck with this. Right, 21. We've got a vectors question. OAB is a triangle. OPM and PAPN are straight lines. Okay, O to A. So let's do that in one color. That's A. Right, O to P is B. We know O to P is in the ratio 3 to 2 to P to M. So altogether, there's 5 bits. So this bit is 3/5 of it, and this bit is 2/5 of it. Okay. And I'm trying to work out O to N and N to P. Right, so let's go step by step. Let's first say, how would we get from O to N? So we're going from, we want to go from O to N. We don't know what the ratio is here. So we'd have to go from, I think, from O to N. So let's see what we do know. We do know how to get from A to B. We could get from A to M. And then we could get from O to M, we can calculate. And then we could work out from O to P. And we could work out A to P, which means we could work out A to N. And then we could work out the ratio with it inside and match the A's to the B's. I'll show you what I mean. Right, let's go step by step. So we're going to try go from A to N in different ways. So, because we're trying to work out what this ratio is from O to N and N to B. Okay, so what I'm going to say is let's find, if ever you're confused and it doesn't make sense, just try find things that you know. So let's say I know A to B, so prove you know how to do vectors. A to B is minus A plus B, because I go down A and up B. I know to go from A to M, I'm going to go from, I know M is the midpoint, so this is half and this is half. So A to M is half of that. It's going to be half of A to B. So minus a half A plus a half B. So that tells me to go from O to M, I must have to go from O to M. I'm going to go from O to A plus A to M. So I'm going from, let me just try to do this for the light, O to A and A to M. My face out of the way. So we end up with A minus a half A plus a half B. When we put that together, we get a half A plus a half B. Right, now how do we go from O to P? Well, we know from O to P, which is one of the things that I want, which I know is 3/5. So O to P is 3/5 of a half A plus a half B, which gives me 3/10 A plus 3/10 B. A to P, so A to P is the same as A to O and O to P. So it seems really convoluted, but just find all the things you know. and it's going to slowly make sense. So we're going to get minus 7/10 A plus 3/10 B. Okay, so now if I want to go from A to N, it's going to be some constant of going A to P. Do you agree? So A to N, going here, we don't know how this is split. So we could say going from A to N is some amount of going from A to P. So it's a bit longer than it. So we're just going A to N is the same as X lots of A to P. So X minus 7/10 A plus 3/10 B, right? And A to N, we're going to say, I'm going to go from A to N, it's going to be minus A plus some amounts to here. So call it K, and let's call that bit as X. Okay, that's the additional X bit. So we've got A to N equals minus A plus KB. So now we match them up. Can you see we've got A to N written in two different ways? So we can see that minus 7/10 X is the same as minus 1. So X must be 10 over 7. So that tells us that's 10/7 of the whole thing. And we've got 3/10 of X equals K. So K, and we know what X is. So 3/10 times 10 over 7 equals K. So K equals 3/7. So O to N is 3/7 B, and N to B is 4/7. So the ratio is 3 to 4. I think I know it's so long, and I think I've got a long about way, but it's one before the end of the paper, and it's a really long question. So a ratio is 3 to 4. What I'm going to do is I'm going to try simplify that, and I will rewrite it out for you, totally simplified, because I think in working through it for the first of you guys, I've made it longer than it needed to be. But you're just trying to find two roots to do the same thing and trying to match the coefficients to be able to find it. Okay, fresh question. Apologies for the longness on there. Right, there are only green pens and blue pens. Okay, so this question you really need to know as well. Probability, algebraic probability has come up in most of the new spec papers. Right, there are only green pens and blue pens in a box. Okay, there are 3 more blue pens than green pens. So what I want to do here is look at what I'm going to end up being to find, because you want to make that your X. I want to work out the number of green pens. So my green pens are going to be X, and my blue pens are going to be X plus 3. Okay. So that means my total number of pens is going to be X plus 3 plus X, so 2X plus 3. Okay. Simon is taking 2 pens at random. So he's taking 2 pens at random, and we want 2 pens of the same color. So we're going to have green, green, or blue, blue. In probabilities, and is times, and or is add. So the probability of green and green, so green, green, is probability of getting green the first time, which is X over 2X plus 3, times by green the second time. Now, if I've taken out a green, I now have 1 less. So instead of X greens, I've got X minus 1. And instead of 2X plus 3 pens, I've got 2X plus 2 pens. So that's green and green. And now we're going to have blue and blue. So we've got X plus 3 over 2X plus 3 times by, I've taken 1 out. So now I've got X plus 2 over 2x plus 2. And what I want to do is I want to add these two expressions together, right? So we're happy with those expressions. Getting those expressions will get you 2 out or 3 out of the 6 marks. But we know when we add them up, we get this value. Right, so I'm going to scroll up to make sure you've got those expressions down. And let's do these. Let's do this. So now what we have is we had x plus 3, x plus 2 over 2x plus 3, 2x plus 2 plus x over x multiplied by x minus 1 over the same thing. And that equals 27 over 55. Right, there's no obvious straightforward way to do this. We're just going to open out all the brackets. The bracket on the bottom is the same. So we've got 4x squared plus 10x plus 6. On the top, we've got x squared plus 2x plus 3x, so plus 5x plus 6 plus x squared minus x over 55. All right, so we simplify that. We've got 2x squared plus 4x plus 6 over 4x squared plus 10x plus 6, 27 over 55. We can divide it by 2, so we'll get x squared 3, 2x squared plus 5x plus 3 equals 27 over 55. Still really big numbers. Now we're going to cross multiply. So the 55 is going to come up there, and that's going to come up there. So we're going to get 55 lots of x squared plus 2x plus 3, and 27 lots of 2x squared plus 5x plus 3. Okay, so if I open out those brackets, I've got 55x squared plus 110x plus 165 equals 54x squared plus 135x plus 81. And I get, if you're in an exam, you might go, have I done this wrong? There's such big numbers. But hopefully you now realize if you move everything to one side, you get x squared minus 25x plus 84 equals 0, and this factorizes. Factors of 84, 21 and 4, x minus x minus. So x can be 4 or x can be 21, but because we're told that it's more than 12, we cross that out, and the number of green pens is 21. Whew, that was very long. Apologies for question, I can't remember which one it was, 21, which went a bit muddled, but we got there in the end, and we can redo that later. Anyone doing AQA? I'm going to try do an AQA foundation and higher paper in about half an hour, if that's useful at all. And I will see some of you maybe then. Apologies, it lost connection halfway through on TikTok. That was TikTok. But you can log in and hopefully see this on YouTube.